Now we have a few more problems. We want you to geometrically construct a graph representing x to the p if the y factor is 5/2. Now, in the preceding, we constructed the graph for y factor 3/2. And after this video, I'll discuss how we might solve a selected number of the problems in the preceding video, just in case you have trouble getting started with these. But I recommend that you do your best to solve these problems without referring to that video. If you're totally stuck, that's what that video is for. Okay, so we do this. The graph, when you construct it, should extend from the lower left or near the lower left excuse me, to the upper right of a nice rectangular graph window. Here would be an example of a nice rectangular graph window. A graph window this high and this wide would not be a nice rectangular graph window. Now, a graph window could actually be wider than it is high. It could be similarly higher than it is wide, but you don't want it to be too narrow in either direction, or everything gets flattened out and you don't get a good picture of the behavior of the function you're graphing. So we want it to start down here somewhere close to this part of the window and end up here somewhere close to the upper right, lower left to upper right. Or very possibly, sometimes you'll have a graph that decreases. You want to start from the upper right, upper left, and extend to the lower right. Now, you can have any kind of a curve in there. I'll draw maybe a typical curve that you might get for some sorts of graphs. Well, that wouldn't be a good graph for a function because it's not single valued, but you might have a set of parametric equations that would give you a graph of this nature. And if you've been through a pre-calculus course, you should have, for the full course all the way through the trigonometry and parametric equations and so forth, you should know what parametric equations are. But again, it's one of those things that is often simply omitted from the course for no good reason, but for the understandable reason that it's difficult to cover everything. Okay, that shouldn't prevent us, but it does, and I can be a victim of that as well as anybody else. Okay, anyhow, enter the editorial comments. So we want to construct that graph in a window that looks in a rectangular window that's not too narrow. Okay, just ballpark, it shouldn't deviate from square by any more than a golden rectangle, if you know what that means. It means it shouldn't be more than about 1.6 times as wide as high, and no more than 1.6 times as high as wide. Okay, now, then we want to estimate f of 1/4, f of 1/2, f of 3/4. Now remember, f of x is this function whose graph you've constructed. Or, of course, you've constructed an approximation to the graph. And again, I'll say this graph can be constructed with compass and straight edge. You should understand how it could be constructed with compass and straight edge. You don't necessarily have to use compass and straight edge to construct it, but whatever you do, don't go measuring things. Don't use any kind of a measuring device or any kind of a scale. Use your eyeball. It'll get you a closer and more profound understanding of the graph. And if you can't do it by eyeball reasonably well, do use compass and straight edge. Okay, anyhow, we want to estimate those values of the function, so that's fairly easy to do because we will have marked a point 1, 1 near the right boundary. So on this curve, we might say that 1, 1 is here. And 0, 0 might be here. So now we can draw an x scale and a y scale. And parentheses didn't turn out very clear there. Okay. Now, Also, solutions of the equations f of x equals 1/4, f of x equals 1/2, f of x equals 3/4. You should be able to make a good estimate of all those quantities based on the graph once you've scaled it by choosing the point 1, 1 and marking the point 0, 0. Again, you get your x scale, you get your y scale. And again, excuse me, eyeball that scale. Don't measure it off. It takes extra time to measure it, and you aren't thinking about what you're doing when you measure it. Well, yeah, there are plenty of things you can think about in measuring it, but don't do that unless you're totally desperate. Okay. Now, I'll also comment, if you've got the 1, 1 point, you don't need to measure anything to get the x equals 1/4, x equals 1/2, and x equals 3/4 points. You just go halfway from here to the 0, halfway from here to here, halfway from here to here, and you have 1/4, 1/2, and 3/4. And you can, of course, do something similar with your y scale. Okay, well, then, using the 1, 1 point on the same set of axes, construct the graph of the factor 3/2 power function. Now, we already constructed that. We constructed that in the preceding videos. Okay, so you would have to repeat that, but on the same graph, okay, on the same set of coordinate axes. So you'll have the graph of one function and you'll have the graph of the other function, so that you can compare the two graphs. Now, let's call this 3/2 power function g of x, and estimate g of 1/4, g of 1/2, and g of 3/4. Very easily done. If you're able to estimate it for f, you can estimate it for g. Then estimate f of 1/4 over g of 1/4, f of 1/2 over g of 1/2, f of 3/4 over g of 3/4. Again, I want you to do this without calculating it. I want you to do this by viewing it. In other words, if your x-axis is here and your f of x value is here and your g of x value is here, or let's say this is your g of x and this is your f of x, then what do you estimate g of x is as a function, as a percentage of f of x? That looks to me like about 40%. This looks about 40% of this. It's not a half. Half is a little higher than this point, but it's pretty close to half. So I'm going to say that that's about 40% of this, so that if this was f of 1/4, sorry, if this is f of 1/4 and this is g of 1/4, then f of 1/4 over g of 1/4, this divided by this, would be about 0.4. So just as an example, you can visualize that. You can visualize that to the nearest tenth. You should be able to estimate a ratio to the nearest tenth. Now, you might or might not know exactly how to look at the graph to do that. You might have a little trouble with that, but you might not. Okay. Then for x between 0 and 1, what can we say about the values of f of x over g of x? Okay, there's a statement we could make about the values of f of x over g of x. And then there's a statement we could make about the trend of these values. As x goes from 0 to 1, what's the trend of f of x over g of x? And say as much as we can about the trend of those values. Okay, then what's going to happen to f of x over g of x and to the trend when x goes bigger than 1? Our graph only goes up to 1, but what's the trend, so forth, how the values behave, what's going to happen beyond that, and how can you maybe justify that? How could you prove that that would be the case without actually constructing the graph, just based on the 3/2 and the 5/2 factors for the two different functions?